warm and quiet at just the right time. Will's told me to make this quick. If anyone knows me, I never listen to what Will says. I've got things I want to say, and I will be saying them, Will, so you have to live with it. First and foremost, obviously, I want to say good evening and a very, very warm welcome to those of you. Am I moving forward?
No microphone.
Oh no. So this is like double control. Okay, is this better? Great, thank you very much. I'll start again. It's great to see you all here. I know we're going to have a very good evening, and I want to extend a very, very warm welcome to those of you joining us here in person, in this room, in front of this equipment, and those of you that are obviously joining us online. We're here today at the Creative Hub at the University of Northampton, and we're here for the inaugural lecture by Professor Will Wise. My name is Cathy Smith, Dr. Cathy Smith, and I'm Dean of Research and Knowledge Exchange at the University of Northampton. And I'm here sadly today to represent the Vice Chancellor, who is unable to join us due to illness. As Dean of Research and Knowledge Exchange, it gives me great pleasure to celebrate the achievements of all our staff who have excelled in their chosen field, and particularly those who have gone on to achieve professorial status, as Will has done. And this might be through exceptional research, exceptional learning and teaching, or exceptional enterprise endeavour. And I think Will would actually fit into all of those categories. I want to say, for me, personally introducing Will is a particular honour. Will, for me, is a colleague and a friend to whom I have the greatest respect. And I'm now going to introduce a little bit of Will's background prior to him giving the lecture, to give you some sense of how Will has arrived at where he has. So, Professor Will Wise is a professor in leather science, and he is the research leader for the Institute for Creative Leather Technologies. He is a chemist by training, as if you wouldn't guess. Having undertaken a BSc in chemistry, an MSc in green chemistry, and a PhD in bioorganic chemistry at the University of Leicester. While maintaining his roots in chemistry, Will subsequently diversified and undertook postdoctoral research within Professor Andrew Abbott's group in the field of ionic liquids, deep eutectic solvents, and their applications in materials science. Will worked on a range of projects during his time as postdoctoral research assistant. He was part of the team that won the Royal Society's Brian Mercer Award, but it was probably his work on eggshell plastic, I had to look that up, that got the most media coverage. In May 2014, Will started as a senior lecturer in leather science at this university. Despite moving into a field seemingly far from his chemistry roots, he has continued the tradition of applying pure science principles to the development of new leather technology, moving the industry forward by pushing the boundaries of what is currently possible. And Will maintains that when you understand the field of leather science, it isn't actually as far from his roots in chemistry as you might think. And I think we'll probably get a further sense of that today. Will was a previous member of Senate and currently sits on most research and knowledge exchange related committees at the university. He is active in knowledge exchange, business engagement, and also income diversification within the university. Externally, he is president of the Society of Leather Technologists and Chemists and has roles in the International Union of Leather Technologists and Chemist Societies as a member of the International Union of Research Commission and the International Union of Training Commission. Since co-authoring Tanning Chemistry, The Science of Leather, a book of nearly 700 pages written for a global audience, and the only treatise in the world of leather science, he has, as you would expect, become a regularly invited speaker at international conferences and at international events. Will's global reputation and the impact of his research was recently recognised when he was made a Fellow of the Royal Society of Chemistry. Will has maintained that he feels very lucky to have made such rapid progress in his career, but also recognises, and I think this is incredibly important, that he wouldn't have been able to seize the opportunities that have come his way without the support of his family, especially his wife and children who are here with us today. Family members are often the unsung heroes of any professorship, and I extend an especially warm welcome to you. Colleagues and friends, please welcome Will to present his lecture. Thank you.
Thank you very much, everybody, and welcome. I've known Kathy, as she alluded to, for some time. She's been a great supporter and mentor for me whilst I've been inside this institution. And I have to say that that introduction could have gone one of two ways. And thank you, Kathy, for choosing the slightly more formal approach. That was greatly welcomed. I confess I've struggled to write an inaugural, trying to balance what I do, which is really very highly scientific, to make it accessible for everybody with a whole range of backgrounds, and do so to cover 10 years of work and over, and condense it into roughly a 1-hour lecture is quite a challenge, but here goes. Oh, I need a slide. Marvelous. So I understand it's customary to make sure that you put a photo suitably embarrassing of you as a child when you do your professorial lecture. And so what you can see there is me sat on my father's motorbike, aged, well, I don't know, about 18 months old. The key thing is that despite my arrival into the leather world in 2014, the material far outlives me. There are recipes that exist from 5,000 years ago, and that means we were making leather far longer than that. And leather is all around us, every single one of us. And because I'm a lecturer, I like to have a bit of audience participation. So I would like you, please, to raise and hold your hand up if you own a pair of leather shoes, a leather sofa, leather seats in your car, a leather handbag, leather watches, leather belts. And now I want you to look around the room. Look how many hands are up. In fact, I don't think there is a single hand that isn't raised. Thank you, everybody. The reason for this is because of the breadth of those material properties that offers. It's a hugely versatile substance, and I hope that what I'll be able to do is, as we go through, is explain some of that, and also how some of our research has tackled the problems that leather face. I knew that would happen. I might just do new slide, please. Another suitably embarrassing photo. I do quite a lot of schools outreach, and I think that's incredibly important as a part of what we deliver here at a university. It's breaking down those barriers, going out to colleges and talking to A-level students, to GCSE students, and to considerably younger students, I think is really important. In fact, this is only the second most nervous I've ever been, because the first most nervous was about 2 months ago when I went into my youngest daughter's class of about 54 and 5-year-olds, and I can assure you none of you will critique me as much as they did. Okay. And somebody, when I went in, one of the pupils said, "How do you become an academic anyway?" And I thought that was actually really quite a nice part to sort of start off at. For me, and this, everybody, every academic in this room will have a subtly different approach, a different story to tell. But for me, it started with a natural inquisitiveness. I wanted to know how things worked, what made them tick, what was going on. And in fact, I understand that I was even at least a partial reason for a head teacher retiring. And this wasn't for those teachers that are sat on the front here, not because of my behaviour for a change, but because I used to sit and watch programmes with my mother and father, things like Horizon and Understand. And aged just 4 years old, I explained once when my head teacher said, "And what did you do at the weekend?" the concept of molecular mobility within a polymeric system. And I apparently used that terminology as well, because that's how my dad explained it to me, and I stretched. And it was a few weeks later that the head teacher saw my parents in town and explained that at this point, he really did decide it was time to hang up his coat and retire as a head teacher. It's definitely died. We'll try switching it on. That might work better. So, I knew at least one of these teachers was going to be here today, but it turns out I've managed to kill two birds with one stone. I will tell you now that I've never been a person that's accepted normality. And the teachers from my secondary school and those teachers that taught me when I was in primary school, of which I understand at least two of them are viewing this online, will probably testify to that fact. My year tutor, Mrs. Burrows, sat here nodding. Indeed. And I think that's important to recognise, because this is a theme that runs throughout why I am an academic and the questions I ask. It's also important to recognise, and I'm open about this, that I did not find school easy. I was in a lot of trouble fairly regularly. And that is an important message to put across, because I was supported through that process, and it made me a better person for it. And that is all part of this journey that I have taken. That works better now, switched it on. So, I got to 16, I got my GCSEs, and they weren't straight A's, except in science, I hasten to add, which were straight A stars. But I didn't get straight A's, and I decided I was going to try and do some A-levels and embark on a career as a professional cyclist. My mother at some point metaphorically put her arm around me and said, have you thought about maybe doing a degree just in case the cycling thing doesn't work for you? You've got something to fall back on. And as you can probably tell from my physique, the cycling career didn't go according to plan. And actually, I was able to pursue my way through getting various different degrees at the University of Leicester. And as is mentioned in the introduction, where I really started to pick up a passion and where my passion took off for leather was indirectly through my postdoc research, because this fundamentally was dealing with problems that industry had, and in some cases it was big industry as well. And that's really important. I really enjoyed the fact that big industry came to us with an issue, we worked on it as a group, and we solved, in most cases, the problem, and that was able to then turn around. And this is something that I do now regularly in my job here as well. So that passion, not doing blue sky research to the same extent, but really solving real problems that industry has, is really key. And in 2014, I made the jump to Northampton, thinking to myself, well, teaching leather science can't be that difficult, can it? And then I realised that this was my starting point. Just the starting point, and those students who I've seen, some students floating around, will know that they have to hack through this book in 3 years if they're doing a BSc, and if it's a master's, it's just 3 months, because I teach the whole thing. And there's master students now already smiling. And actually, it's a really highly nuanced subject. It's not as simple as just following a recipe and being able to turn out perfect leather. I think the analogy is probably very close to making some wine. We could all have a go at making wine, but many of us are far from being able to sell it. Throughout that entire process, leather has always been important to me. And you can see a bit of a theme here, I'm guessing, with the number of motorbikes. I tried to follow in my father's footsteps and take up motorcycle racing. I did a few. I think it's fair to say I was nowhere close to as good as he was. This particular image, and I'm going to stretch across because I haven't got a pointer, is me age 9 going out on the back of my dad's motorbike. Notice I'm wearing a red leather jacket. On the bottom, on the blue motorbike, this is a motorbike some of you might be familiar with because it still comes into the university today. This is me taking a gentle pootle around some country lanes. And just because it's not all about motorbikes and leather, on the very right-hand side, you can see England fast-paced bowler Matthew Hoggard, who I had just played cricket against. And yes, he did bowl at me. And it is nearly as terrifying as you can imagine. And bear in mind, he was a long way off his peak performance. And the final one that I want to draw your attention to is nothing to do with me per se. The bike on the bottom is my dad at the Isle of Man. And there's a very good reason why I am showing you that. These are the leathers he raced in. And they are still, if I was 6 stone lighter, very serviceable leathers. Admittedly, they've got a few patch repairs. I think they went beyond 79 and probably down the road a couple of times. And my mother was a dab hand at being able to repair the leather. But you can see these leathers are still serviceable. Genuinely, leather that's made motorcycle leathers hasn't changed all that much. And in fact, what's changed is the synthetics that we put inside them for impact protection. The leather itself is fundamentally the same in those as it was in modern day leathers. And that's really important because for me, this nicely starts to tie in the title of this lecture. Because what I need to do and what we do within our department, the whole team does within our department, is we work towards making leather a sustainable option for everybody. And I genuinely believe it is. There are people in this room who will ask questions about what does sustainability mean? How do we measure it? That's a challenge that will continue to go on. And I get the nice bit because I don't have to do that. I can focus on the nice bits that just do the nitty-gritty science. I don't have to do the very, very big questions. Everything we do in our department has sustainability embedded in it. And there's a very good reason for that, because leather lasts a very long time. Those leathers prove it quite nicely. It is a strong material. It is resistant to abrasion, very resistant to abrasion. It's a great insulator, and it's highly flexible. And if you look at materials available to you nowadays, there are very few materials that can cover all of those simultaneously. Yes, there are materials that are stronger, but they're certainly not as flexible. There are some that have a good abrasion resistance, but they're not flexible or strong. And the list goes on. Leather, most of the time, you can make a product that lasts far longer out of leather than its synthetic alternatives. So then the question then, for me, as a part of my learning journey, was why? Where does it get that mechanical strength from? What you see on the left is real leather. It's a microscope image taken by one of my colleagues, Mark Gummer. And on that, you can see the various different structure of what leather is. The top part is the grain. And if you all look at the back of your hand, the grain is the surface that you can see. It's the bit that has the hair in it, and it's a very nice compact structure. Underneath that, you have what we call the corium. And I should mention the fact that our alumni club is called the Corium Club for that reason. It has a fantastic network of fibers that really offer up that strength. And then finally, just below that, another layer of compact fibers that are on the flesh side, where the animal has been flayed. On the right, as means of comparison, you've got a polyurethane-backed textile. Now, to the layman, this might look the same. The idea of these polyurethanes is that they appear to look like leather. But what you can see on that image is, in fact, the textile. And you can see some fibers pointing straight out of the screen at you, as well as some that are woven in and out. And the reason for that is because if you were to use that polyurethane without the textile, it would fall apart very, very quickly. And polyurethane just doesn't stack up, not just from a sustainability perspective, but also from a performance perspective. And there are many other materials that also struggle. So the key then to leather is this structure. I'm going to just turn this up a little bit. So the key then to leather is this structure. And in all of the research that we do in the department, we inspect and study that structure. Because if we lose that fiber structure, you lose that mechanical property. And that can be as a result of something chemical, but it can also be as a result of something mechanical. So I thought, now let's just take a step back. Because I know that Will Wise, age 15 in his design technology class, nice reference you see, I would have said, all right, but why do I care? So there you go. Well, the scale of the leather industry is absolutely huge, ginormous. Around about 1.5 billion hides and skins were converted into leather in 2020. That, by the way, is enough, and this is very conservative assumptions, enough to cover Luxembourg every single year. That's a huge amount of leather. Those animals are as a byproduct of the meat industry. This is completely surplus to requirement as far as the meat. The value of the animal is in the meat and not in the skin. That's a byproduct. So we are doing an environmental good. We are being sustainable by using that material. And it doesn't matter whether you are a meat eater or a vegetarian or a vegan. I think most of us will agree that if you're going to kill an animal, you make sure you use as much of it as you possibly can. And that's really important. In that same year, 2020, the leather goods market alone was worth just shy of $400 billion. Now, if you consider that that's around about 20% of the leather market in total, that means this industry is worth over $1 trillion. Now, that is a truly staggering number. I can't get my head around. I noticed, by the way, nobody sat on the front row with the experiments. I was going to get the front row to stand up and see if we could get enough people for zeros to try and represent what a trillion is. It's a truly staggering number. But to give you some idea of how big that is, we hear a lot in the media of talk around sugar and the sugar industry. The leather industry is twice the size of the entire sugar industry. In fact, if you combine rubber, coffee, cotton, and tea industries all together, the leather industry is bigger than them. So this is a truly astronomical size industry. And that, I feel, is really important because it means as an industry, we have a real impact on achieving sustainability and making a difference for generations to come. And on that slide, what you will see is the UN SDGs, Sustainable Development Goals. Now, the leather industry is actively working in at least 14 of those, and there may be people in this room that would argue that they're working in all 17. And as a part of that, and as a part of the research that ICLT does, that I've been a part of, but also my colleagues, we have worked on a project that overlaps with one of those 14 all the way through, one of 14 of those 17 all the way through. Now, most of our research is focused on environmental sustainability. There's 3 chemists in the department, so it seems natural that we would lend ourselves towards that. But I will say this much, we do also have some social sustainability. And I was involved in a project, a PhD project, which was looking at exactly that. Now, unlike really big industry, petrochemicals, for example, the leather industry is really accessible by the layman. If you have just one cow and you farm it wherever you are, small holding, and you kill that animal, you can make leather in just a single vessel. And that means it's hugely accessible to everybody across the world. And that is especially important for those in the developing areas of the world. So we have a direct impact on that. And alongside Kathy Mortimer, who was a supervisor on this project from the business school, and myself, she, who's in the middle, delivered work, or a PhD project, very successfully defended, looking at the drivers that drive this going forward. Now, the important thing for me that fits what I know and understand of the leather industry is the fact that it seems like if you are in a $1 trillion industry, it'd be highly competitive. But the main thing that came out that really hit me hard here was the fact that the actors, the people involved in this, worked collaboratively towards creating a better future. Not against each other, not competitively, but collaboratively. There were common goals, threads that ran throughout every single business that went into every single sustainability report. And I think that really mimics what I know of the leather industry, this collaborative, and I hasten to add, very friendly industry. There are, however, some challenges, and if I now divert a fraction towards the environmental side of things, one of the key ones is a lack of understanding of the material, and particularly its mis and disinformation that surrounds the whole industry. Many of you will be familiar with this kind of an image. This one is taken from Marrakesh, and it is really common to see on the internet because that is how we make leather. Only it isn't. It isn't at all. It is there for being a tourist attraction. The vast majority of leather is not made by people stamping on it in pits. It is made in ginormous processing vessels. These drums that you see on the image on the right are 4 meters in diameter, typically 1 to 2 meters off the ground. And I like that image because the forklift truck gives you some idea of scale. And although you might not be able to see it very well on those small screens, that image goes back and back and back. Each of those drums holds about 10 tons of leather. So this is a ginormous operation. This is not somebody stamping on something in a pit. So that already is an element of mis and disinformation. The other thing is that there are very few people that are examining the fundamental science that underpins leather manufacture. Northampton has always been at the forefront of that, way before I was here. And there is probably a handful of others across the globe that are involved in that research. It isn't until you've got a fundamental understanding of what you're dealing with that you can truly use a scientific approach to make it better. And I think that's quite important. Another challenge that faces the leather industry is the use of water. There is a debate over how much water per ton is used, and the numbers can go from anything from 15 tons of water per ton of leather upwards. And that's something that we need to try and improve if we are to maintain being the most sustainable process that's applicable across the globe. The use of chemicals, and those that are involved in leather, don't jump at me yet. I'm going to explain this, okay? The use of chemicals is a bit of an issue. And how we measure sustainability. There are people more knowledgeable than me in this room who know how to measure sustainability, but it is certainly something that's quite important that we get a handle on, because wouldn't it be great to walk up to a garment in a shop and have a number that told you how sustainable something was, so you could do a direct comparison? I think we're a long way off that, but it would be great if that's what we can do, and there are people who are working on that globally. So water then. Let's start tackling water. The thing is water isn't just a solvent when it comes to leather. When we're processing leather, we use it as a means of getting the chemicals from the outside of the leather to the inside. It transports those chemicals. It supports the system during that manufacture, and importantly, it's integral to the performance of leather. So when you start to look at it right down at a molecular scale, if it wasn't for water, we would have a really big problem with our collagen. But the challenge is that irrespective of the numbers you use per ton of leather, we produce it as a waste stream. And this is really important because that means that you've got stuff in your water, whether it's come from the leather or whether it's something you've added, that you have to remove. And that's a really big factor for improving the chemistry that we try to use in leather manufacture. In fact, it's so important that we embed it throughout our entire teaching program. Tony Covington was once asked, well, what do you do as far as sustainability is concerned? And the answer is, well, just about everything we do is centered around sustainability. It's completely inseparable from the modules. You don't single it out. It's embedded in what we deliver. But remember I said I don't like accepting the norms, he says, smiling at his year tutor and head teacher. I came in and I thought, well, why do we have to use water? Where do we go with this? Now, what I'll do is I'm, of course, going to do some demonstrations. And what I was going to do, we had a Deputy Vice-Chancellor who was leaving today, and I thought maybe what I could do is get somebody who's leaving to perhaps set fire to something. And inside this building, wouldn't it be great if they set fire to something? And I think we've just about got enough headspace. But unfortunately, she's not here. So what I need to do is to find a willing volunteer who is imminently going to leave the university, perhaps doesn't care if they blow the building up. A dean, perhaps. John. So, this is important. Whilst John, if Stefan can get him rigged up, whilst John's getting himself rigged up, I think what's important here is when we talk about solvents, we normally think of organic solvents. And it's true to say that the leather industry used to use them an awful lot. And so I need the solvent, Stefan, which is somewhere over there on the blue trolley, I think. So we used to use it a lot, particularly in finishing, which is the last process that we will have gone through in leather manufacture. It was also used quite extensively in fat removal. We used to use paraffin, which is just a solvent in this case. And it's actually really interesting that even as recent as my time, and we're talking just 5 to 8 years ago, there was a really massive international company who was investigating whether or not they could use a really flammable solvent to do some processing in the leather industry. But the challenge is that organic solvents have a number of drawbacks. Firstly, they are quite toxic to workers. Anybody that's sniffed a solvent will know. They are quite difficult to dispose of. Water, once it's clean, you can put it back into the watercourse, but solvents, you cannot. And there is a third thing that I think ought to be demonstrated. And I'm just going to take my lap. I'm sorry, John. It's a trust thing. It really is. So one of the challenges you've got with solvents, as I've alluded to, is the fact that they're really quite flammable. And so those of you who can read can see I've got Will Wise's solvent processing drum here. Remember the scale of those drums in that photo? 4-meter diameter drums. So this is just a little drum, really. Those of you that recognise a water container will, of course, be. And all I'm going to do is just rotate it. This is what a drum would do. And what's happening is all of the fumes inside this drum are gradually building up. They're mixing with oxygen. Anybody like Christmas cake, by the way? Carl, you're looking incredibly nervous sat there. I am disappointed there isn't anybody on the front row. And so what would happen then is you might build up a bit of static charge. There's a spark, a source of ignition. You might have a spark because they're driven by electric motors quite often. There's a source of ignition. You might have somebody having a cheeky cigarette as a worker. So the problem is you've got an awful lot of fumes, a very apprehensive Dean. I hope you realise this is entirely blamed on you if it goes wrong.
Say, the last time my eyebrows were at this month was in the aftermath of a sentence that ran, "Of course the cable's not live. The electrician told me there's nothing live in this lot. Just cut the damn thing."
There we go.
It was nice. Yes, yes.
Just so you know, I've got the fire extinguisher down here. Just
and the blanket.
So just give me a tick to get away from it, John. Okay. It did go quite well. John, you're just relieved you didn't lose your eyebrows. Now, the key thing there is what we've got to imagine is this happening on a much, much larger scale. And clearly, despite the fact that I have my Thunderbird's brains glasses on now, this would be quite a significant issue. And I think, if we could just flick back to the slides, I think it's visualised something that I would happily do inside a school. It visualises some of the challenges that we would face if we were to use organic solvents. So let's rule those out then. I was very lucky when I arrived that there was already some research being done on trying to look at waterless processes. And somebody came up with the bright idea of copying what was done in the laundry industry and replacing water with these beads, nothing more than that. So you might say, well, why on earth would you want to replace the water with the beads? Well, firstly, of course, it's about the reduction of the water. And secondly, when you've filled that full of leather, that would be the kind of level of water that you might see inside your tanning drum, a third full, perhaps. Okay? There's quite a lot of water, and if I was to dip this filter paper into that water, I think we would all accept that this would take on the dye and would be coloured. It's fairly easy, and the leather industry relies on that. But what about if I use considerably less water? Here I have the same solution, but obviously much, much less liquid. And so all I'm going to do is just pour this in, and hopefully this works. Always try experiments before you do it in a lecture. It's really important. And all I'm going to do is just take this and slowly rotate it. And what happens is the beads get coated in the liquid, and as the beads get coated in the liquid, they transfer it through to the paper. And this is really important, that we've still got something in there that flows. Because if you were to do a process in a tanning drum without any water, the chemistry might work. There are people in this room that have done that. But the challenge is the damage to the drum that comes about, and the fact that it isn't always an even process, because you can't deal with it nicely. I should have thought about this before wearing a suit, shouldn't I? That's another failing, huh? So all I'm going to do now is just take this out, and hopefully I'm going to put it back in again because I've got nowhere to put it. You can all see that that filter paper has very nicely taken that green, very evenly, using less than a tenth of the amount of water that's involved in that process. And I think that is a really important step in the right direction of being more sustainable. Need the slide, there we go. Now, this was, in fact, part of two very successful knowledge transfer partnerships. These are projects that are funded by the UKRI Innovate UK. The first was the one that I arrived part of the way through, that was actually looking at taking that technology from the laundry industry and putting it into the leather industry. Was it even possible? The second was one that I was the supervisor on, and in fact the KTP associate is somewhere in here. Callum, I can't see where, there he is, he's over there. Callum was the KTP associate on that particular project. And once we realised it did transfer into the leather industry, then my imagination started going. Then I started going, well, I wonder what we could do with it. I wonder what limits we can push. And again, I go back to my school career where I definitely pushed the limits on a regular basis. So this was about this inherent idea that I had of just trying to see where the limits were. What could we do? And importantly, could we learn from history and take technology that's very old and transfer it to something that's considerably more modern? Now, much of the work, sadly, and this will be a recurring theme throughout, is tied under confidentiality, and I can't go into the details of exactly what we're doing. But suffice to say that it is now implemented in full-scale industry. Deep eutectic solvents. Well, I came from Andy Abbott's group, and of course, deep eutectic solvents were the main research area. And this is something, therefore, that I could do by transferring across what I had learned in Andy's group and transferring it across to the leather industry. What are deep eutectic solvents then? Well, in chemistry terms, they're a fairly new sort of solvent system. They're made by taking a salt and mixing it with something called a hydrogen bond donor, and that breaks down what we have as a solid, and it breaks it down into a liquid, and that liquid is entirely tunable. And this is really important because it means that I can look at what I want to dissolve, and because like dissolves like, I can then actually make something that will deliberately dissolve what I want it to dissolve. Now, I'm going to ask my colleagues from ICLT to go and find themselves, if you can just go and grab some of the pots, because, again, audience participation is important. We don't want Don hogging all of the limelight, so I have got some experiments that you will all be able to do. Don't look so worried, those of you. Because making a liquid, and I must credit Andy Abbott's group for allowing me to use this video, this is not mine, is very, very simple. And I've done this for the benefit of those people who are listening virtually. What you do is you take your two solids, you mix them together, and as you can see in that video, they form, in this case, a very colourful liquid. And this video isn't sped up. This is real time. And it's really counterintuitive when you think about it to take two solids and have them turn into a liquid. So I'm going to stand here and try and do this for those virtually, just to prove that a professor does have an element of truth in what they say. But you are going to be able to, he says, once it's all been tipped and mixed together, you're going to be able to do exactly the same thing. So the two substances that I'm going to mix together in front of you here are going to have already been put together for you over there and then passed out. Any that have got the lid screwed on, perhaps we can use John again to go and start passing them round. That would be really useful. John, sorry, no rest for the wicked. Right, so what I have here then is, in this case, a zinc nitrate, and I'm going to mix it with choline chloride, and that's exactly what you guys are going to do. And hopefully what you can see is a solid and a solid. And this should, he says, go very, very well. So if you could just hand them round. I must say, I'd like to think this would go without saying, but I will say it anyway, please do not open the tops and drink the contents. It is part of the risk assessment that I have made that I assume most people will not do that, okay? Now, you will have to shake it quite vigorously. Don't think that you could, Richard, just get away with tipping it slowly, okay? It needs to be done quite vigorously. And actually what you'll find is that this gets quite chilly, quite cold. And that's an important observation, because a lot of what we do in the leather industry has a lot of links with thermodynamics and kinetics, and it's something that we have to be able to look at ourselves. And so all we're doing here is taking those two solids, shaking it, giving it a bit of energy, and hopefully, as they mix and combine, you will see that it starts to first of all go sludgy. And once it goes sludgy, it gradually turns more and more into a liquid. And if you put your hand on it, you will find that it's quite chilly to touch. So the students in the room, of course, particularly my first years, will instantly say it's an endothermic reaction, Will, won't you? Thank you. Okay. Now this one is particularly chilly, and I'm happy just to pass this around as well, but I will do so with me holding it so you can feel how cold it is. So this reaction is taking in energy from its surroundings, and it is combining it through to make that liquid. And that means you have just made a deep eutectic solvent. That's one example of many. I can see you've not got some yet, so you can see how cold it's getting. Okay? So this is a really important process, and what I did, learning from what I knew from my work that I did as a postdoc, was I tried very hard, and with a lot of help, to transfer this across to the leather industry. If we can flip back to the slides, thank you. Now, the really interesting thing about this is because they're tunable, they provide an awful lot of advantages. The first is that they are much better at dissolving things because we're not working with just one solvent, water. So in the top left image, you will see in the center tube something called mimosa. That's a vegetable tannin. And when it's mixed with water, it's partially soluble, but the vast majority of it just stays as a suspension. That solution is really cloudy. On the right-hand side of that image, you will see a deep eutectic mixed with mimosa, and the mimosa has completely dissolved. And that's really important when it comes to processing, because that means I can instantly, with a very high concentration, get that vegetable tannin to penetrate through the leather. It also provides you access to chemistry that's not available in water. And the bottom left image shows Sudan black. And what we did on this particular piece of work was we took the dye and we put it into water. It doesn't mix very well with water. We left leather in there for 48 hours, and when you pulled it out, the leather had barely changed colour at all. When we did the same with its much better dissolved deep eutectic, it dyed the leather through in 15 minutes. So really quite a contrast. And what was nice about it is because this dye is not water soluble, when I rinsed it in water, the water didn't take any of the dye. None of the dye came out of it, which is a really important property to have in leather. And finally, A lot of what we do is solution chemistry. It is when we're working with water. And so far, the two examples I've given you is solution phase chemistry. Just instead of using water, we use a deep eutectic. But you can make these deep eutectics into active ingredients. So they're not solutions anymore. You can just apply them directly to leather. And we proved this worked with chrome alum, something that we used to use in the leather industry, where we made a deep eutectic with it, put it on the surface of the leather, and was able to tan that leather. So it made a chrome tanned leather instantly. Now this is proven on a lab scale, proven very well, and we're working currently with an international chemical company to see if that can be put through to full scale. And they have a number of targets that they particularly want to work on. Toxicity, use of chemicals. I did say I was coming back to this. Yes, leather uses chemicals in its manufacture, but I hate the term chemical because everything's a chemical. We take chemicals when we eat. We take chemicals when we have medication. We have cosmetics. They are chemicals. Arguably, water is a chemical. So the idea that leather uses chemicals is one that doesn't really hold water. Please excuse the pun, for me. Lots of the chemicals we use have very low toxicity, and very few of them have a high toxicity, if any at all. And the main reason for that is because they're banned under legislation. We can't use them, even if we would have wanted to. But there is some questions that have arisen, and there is people who ask questions, very pointed questions, at the leather industry. And one of them that I was directly involved in particularly was around the use of chromium and what chromium did. Now, about 80% of the world's leather is made using chrome salts, and the chrome salt of choice is chromium-3 sulfate. The key thing in that is the word 3, because chromium has two oxidation states that are of interest to the leather industry. Chrome-3, absolutely fine, no problems at all, and chrome-6, which I'm going to be honest is hideously toxic and really, really rather nasty. It's one of the few chemicals I don't particularly enjoy handling. So the challenge we've got is these two oxidation states are in permanent balance with one another. What we do in the leather manufacturing industry is we deliberately move that balance in the favour of chrome-3, the non-toxic version of chromium. But it didn't stop some people who had perhaps got a bit of an axe to grind asking the question, is chrome-6 a real problem? Should we be moving away from chromium? And so this is something that myself and Dr. Stefan Davis, who's sat over there, the other geek in a white lab coat, sat over there. We were working on this, particularly this question. And remember how big the industry is. This means we were working on a project that will impact on 80% of a $1 trillion industry. So this isn't small little projects. And the main question was, well, how do we measure it? And there's lots of very clever people who said that's really easy. The problem is they were wrong, because it's even more difficult than looking for a needle in a haystack when we start to look at the quantities. Let's be honest about this. Looking for a needle in a haystack is really easy. You just get a metal detector because they're so different. The problem we've got with chrome-3 and chrome-6 from chemistry terms is actually they're very, very similar. So it's more like looking for a slightly darker brown shade of straw in your haystack. And that gives you some idea of how hard it is. So whilst we were working on that, Stefan and I discovered some pretty fundamental flaws in an international standard. There were some problems with the way in which the leather was being assessed. And what I want to do here is just prove to you how easy it is to get chrome-6 wrong. Remember, I did say I didn't like handling it. I am actually going to put gloves on. What I have in this pot is a solution of chrome-6, potassium chromate, in a really quite nasty solution of sulfuric acid. This is mostly, although it'll be an equilibrium, see, sweaty hands and gloves don't work, do they? This is going to be, as the colour indicates for those who are chemists in the building, the fact that it is largely chrome-6. a nice orange or a yellow colour for chrome 6. The challenge is, there we go, it is actually fairly easy to reduce this. And this is something that's really important because leather itself is a reducing environment. So if chrome 6 is generated, there's absolutely no chemical reason why it can't be reduced back down. All I have here is a really small amount of zinc powder. I'm just going to tip this in. And hopefully what you can see is the zinc powder initially starts to mix with it. It generates a bit of hydrogen gas as it's mixing. And if I've done my chemistry calculations correct, over a period of the next sort of 30 seconds to a minute, this will gradually change colour to something much closer to a green. It isn't just the zinc that's made that colour change. It is, in fact, the fact that we are generating chrome 3. I'm going to put those in the bin. And just to force it, I can always go and chuck in a bit more zinc. And I'm just going to switch off the stirrer, just so that it sort of confirms that that orange colour is now dissipating. What you're now starting to see is the change to a green colour. That equilibrium is really easy to toy with. It's really easy to play with. And in fact, I'm going to leave that stirring in the background. I'm just very gently, not tightly, going to put that lid on because it's generating gas. I don't want to have a second go at trying to lose John's eyebrows. So this will continue to change colour as that reaction progresses. And because it's so easy to swap between chrome 3 and chrome 6, really simple emissions from an ISO standard can make a really big difference. So Stefan and I published on this. We put this out, we put it across, and at the same time as we were doing this research, the EU tried actually putting together a lowering of the limit, currently set at 3 parts of chrome 6 in your leather, parts per million of chrome 6 in your leather, to 1 part. And our research was able to prove that this is impossible to test for. Absolutely impossible. At 1 part per million, the ISO test that they wanted to follow has an error of plus or minus 1. Now, just to put that into perspective, and I'm stealing this analogy from Stefan, that's like having a pregnancy test from the pharmacy where it says, yes, you're pregnant, plus or minus yes and no. And I think we can all observe that that would be a fairly pointless test to go and buy. Okay? Yet that was what we were looking at. Now, in publishing our data and in responding to the European Chemical Agency's consultation, they took that on board. And in fact, we were mentioned and cited in the response from ECHA when they were dealing with this. And we were part of the reason why, although they are still looking to lower the limit, they've extended the time in which they're going to do that to allow scientists like us at Northampton to develop methods that will actually be able to test down to 1 part per million. And this is ongoing research that Stefan and I are still working on, and we're fairly hopeful we can deliver. So tanning then. The most famous step really in the whole process, and an important one. Most people not in the industry refer to making a piece of leather as tanning. And in fact, it's only just 1 step in at least 7 or more steps in leather manufacture. The primary job of this process of tanning is to stop the leather from degrading. If you left a chicken skin out on your kitchen worktop, or as me and my wife discovered, accidentally switch off the freezer when you go on holiday, when you return back, it doesn't half stink. And there's a bit of a clear up, which I'm very grateful because I couldn't stomach it, and my wife was very good and cleared up what was left of the freezer. If I had known I was going to do that, I could have tanned what was in the freezer and I could have prevented that putrefaction. And that's really important. But there is a secondary thing in that it alters the chemical properties of the skin. And what I have here is a pot of boiling water. It's not quite boiling, but it's certainly hot. And I have some skin. And this skin is what we call pickled. It's not yet been tanned. Okay? And I'm just going to hold up. This is a piece of leather that's already been made, and I can hold up, and hopefully you can see that it roughly matches that size. Okay? So just to match up. And all I'm going to do is just take my hot water and put that skin in. And it almost instantly coils up and shrinks. And in fact, he says, trying to fish it out, probably would have been better to stop the stirrer, wouldn't I? That's all that's left of it. You can see, my chemist's fingers are still working because that's boiling hot water. You can see if I compare these, that the skin has clearly shrunk. And actually, I'm not going to pass this around because it is genuinely really rather hot. But this has gone kind of weird and rubbery and stiff. It no longer has the same properties. That is useless. And it's something that happens when we end up scalding ourselves. Anybody who's had the misfortune of being burned, this is a process. This is why scalding, you end up with a mark that opens up, because that's what happens when you get scalded. What I have here, however, and there'll be a very nervous tannery manager sat in the audience somewhere, is the same skin, but it's been tanned by our tannery manager. Very well tanned, I hasten to add. Okay, same size. And I'm going to drop that in the same boiling water. I can see him looking. He's pretending he's not interested. It's a bit like, you know, that reasonably priced car that they did on Top Gear where nobody was that interested, but they really were. And now all I'm going to do is fish this same piece out. I'm going to try and just let it cool down. Are you ready, David? What you can see is it's not changed its size at all. That hasn't shrunk, and that's all because of the way the tanning agent is interacting with the leather and the collagen. I'm going to make a cup of tea now. So that's really important. If we could just flick back to the sides, please. So it alters the chemical properties. Now, there's a range of things that I have to say that there isn't just one tanning agent. There are many, many tens of tanning agents available. And there's different things that you're looking for. There's cost. There's the mechanical properties. How's it bend and how's it flex? There's physical properties. How's it respond to light? There's chemical properties. You've just seen one example of a chemical property. And you've also got the impact it has on sustainability. And this is an important part of what we're doing, because you've got things like how much energy does it take to manufacture that leather using that tanning agent? What other chemicals do I need to use as a consequence of that tanning agent? And where is that tanning agent actually from? And it's the strive to look at or improve on those things that leads us to improvements in tanning technology. So this takes me on to something that I have worked on quite extensively, and that is the use of aluminosilicates. Aluminosilicates are a really common mineral. I am told 75% of the Earth's crust is made up of aluminosilicates, and it does, I hasten to add, cover hundreds of different types of aluminosilicates, but it is still nevertheless really highly abundant. Now, ICLT did research on this whilst I was still at secondary school. So I can't profess that I am the originator of this research. But whilst I was at Northampton, we had an international chemical company come to us, and they were working on something very similar. And they said, we know you've done this, we know you are the experts, and we want to use that knowledge so that we can make this a commercial success. Now, again, it's a confidential product. Most of these things are because they're tied with companies and they want to protect their intellectual property so that you guys can't go and make millions of quid. But I can tell you this. Question, do they tan? Answer, yes, they do. It's a bit Bob the Builder, this. But I returned back to my original roots as the naughty schoolboy. And what I looked at was the questions, the wider questions that this research raised. And the ones that I particularly enjoyed is going out into industry and really challenging how they had defined things. Was this aluminosilicate just an aluminium tannage? They existed many, many years ago. Well, that was a really important question, and the research we did and delivered as a part of what we were doing proved it wasn't just an aluminium tannage. Is it a metal tannage? Now, everybody in the room here, because you are all fairly sensible people, will go, yes. But according to the definitions that we had in the leather industry, it was very grey. And I took great pleasure standing in front of a conference and telling people that perhaps this wasn't quite as black and white as they had originally thought. Once again, ICLT was challenging the norms, the accepted norms of what we were doing. Vegetable tannages then. The oldest form of tanning. 5,000 years ago, there was no aluminosilicate tannages. We used large molecules derived from vegetative matter. That might be from wood, it might be from bark, it might be from nuts, it could be from leaves. Okay. These structures, and I've only chosen 3 here just because they looked quite pretty. I mean, when I say pretty, you have to remember, as a chemist, this is my form of art, okay? I know there are artists in the room who are scowling at me now, but this to me is beautiful, okay? But it's a really complex structure. And these structures can become even more complex when they're all together. So you might sort of say, well, okay, what's the point here? Well, the point is that tannin agents, veg-tans, were originally used because they were local. In the UK, we had a lot of oak tanning. We had chestnut tanning. We had willow tanning. Why? Because they were trees that we had in high abundance around us. Now, globalization has kind of interrupted that a little bit, because what we are now able to do is to have access to an awful lot of tannages that are much, much broader than this and come from completely different areas of the world. And so that presents a bit of a challenge from a sustainability perspective, because is it sustainable? And this is not a rhetorical question, but is it sustainable to transfer something from South America to the UK to use it when you might have something on your doorstep that can be used just as well? And that's not a simple question. It sounds like it is not. It's very multifaceted. Now, this was actually a knowledge transfer partnership that Andrew Ballantyne, who sat at the back here, was the academic supervisor on, and he worked with Scottish Leather Group, who are leaders in sustainability within the leather manufacture, and they were looking at this problem and looking to see whether they could actually regress. And I know that sounds a bit bonkers, but they were looking at waste sources in Scotland. Can we actually use waste sources of veg tannins in Scotland so that we don't have to transfer things halfway across the world? And this is an approach that can be rolled out internationally, because everywhere in the world there is a local source of those tanning agents. What I will say is that KTP, because I can't tell you the results, nor can Andy, but the KTP was rated as outstanding. There aren't that many KTPs get that rating, and that's because Innovate know the results. They know the benefit that the results we generated are going to bring to that company and to the sustainable story of what leather is. So then I come on to something about a bit more about challenging perceived wisdom. You will look down at your leather shoes, leather handbag, leather sofa, and you will make one observation that you probably don't realise. It's not hairy, and cows are. So as a part of leather manufacture, we remove the hair from the hides. And this really commonly has been done using something called sulfide in an alkaline solution, really quite a high alkaline solution. And the observation for a mechanism that's been known for decades and decades and decades is that it works very well above a pH of 12. It doesn't work very well below 12, and below a pH of 7, it's lethal. And I don't mean that lightheartedly, I mean it is genuinely lethal. But why? I'm not going to go through a reaction mechanism for people, but the key thing for those in the audience is this S2- area here. That is your sulfide, and that is the active component. And what it does is it smashes apart, breaks apart the keratin, and once you've broken the SS linkage, the disulfide linkage, once that is broken, the hair can then disassemble and dissolve into the water. Great. Tick. And guess what? It fits the observations, because here is a very old graph where if you look at a pH of 12 on the bottom, you will see that the S minus minus, S2 minus molecule is generated in a high amount. Below that, it isn't. And of course, below a pH of 12, we observed it didn't work. Why is it lethal below a pH of 7? Well, you generate H2S. And just for those of you that aren't aware what H2S is, it's a chemical that's 1,000 times more toxic than cyanide. So it's not something you particularly want to generate. Great. Everything's tickety-boo. I sat down with Tony Covington in his office. He explained all of this to me. Everybody accepts that that's right, except there was some literature published in about 2018 that observed somebody quietly changed the pH at which S2 minus works at. And what we discovered is in water, any water-based solution, you absolutely cannot generate S2 minus. It does not exist. And if it doesn't exist, that means that mechanism I've just shown you, means those graphs I've just shown you, they're completely wrong. And in 2019, I was able to stand up in front of an auditorium of around about 500 to 600 people, having got them all, just as you did earlier, to put their hands up to say, did you use sulfide to make your leather? Everybody puts their hands up and they went, no, you didn't. And cue lots of groans. This is just because of the person I am and the fact that I like challenging the norms, and I like putting forward new processes and new mechanisms that might be a part of that. Somebody did in the audience, probably a version of me, said, yeah, but does it matter? Well, the answer is, from a technology perspective, it doesn't matter that much. We can still unhair. But it matters to me because I hate not knowing how things work. And it should matter as a wider concept, because it goes back to the point of, if you don't understand how something works, you cannot possibly expect to improve it. So I will very slowly wrap this up. Leather manufacture, very, very simple chemistry. It has to be cheap. The business model that leather operates is largely a very low profit margin, very high turnover. It has to be cheap. But importantly, you are part of a very big process. So if you make a change in that process, no matter how small, it may well have consequences further on down the line. And what you need is people who understand that process, experts, and a scientific approach to be able to make predictions and analyze what you've got coming out the other side. The science of looking at the fundamentals, I should say, and I've not gone into any of the projects where we've looked at that, is not simple. It's really quite complex in places. Some of the work that we've published has used things like solid state NMR. We have been across and fired electrons at pieces of leather at a very, very high rate, just because we can, and sort of see what happens. So it's far from simple, but I've chosen at this point not to go through that. And for me, it's very hard to find a more sustainable material. I cannot find a more sustainable material that is likely to support us for many decades to come because of that sustainability. If it wasn't sustainable, it wouldn't have been made 5,000 years ago and still used today. And diversification. This is important because it's a buzzword in a lot of industry at the moment. Doesn't matter whether it's the leather industry. The university is looking at diversification. It's a word that's really, really important. Leather is known as being one of the best materials, and as a consequence, it has a target on its back. People want to better what leather is and what it can do. And many are now starting to look at the kind of expertise that we have in ICLT to try and drive that change, because they're looking at leather and going, actually, our material isn't as good as leather. Can we copy bits of the leather process? And it might be mechanical, things like staking to try and soften things up. It might be chemical, tanning. Might be one of those things. And those new materials can offer a whole range. They could be cellulosic. They could be based on mycelium, which is, to the layman, is fungus. Okay. It might be that it's collagen-based, just not, importantly, not leather. It could even just be straight petrochemicals, although they typically don't come to us because that is just plastic. And this is now a really active emerging research area for the University of Northampton. And once again, we, because the expertise we have in-house, are leading the way on that. And finally, some pretty unlikely crossovers. Our Vice-Chancellor is a historian. Cathy Smith is apparently a historian and will understand the importance of examining history, how things were done, and what we can learn from it. And we recently had a PhD student supervised by Dr. Annie Lama and Professor Matthew McCormack, who I think is in the room, who was looking at leather made by Egyptians, pharaonic leather. What can we learn from that? How was it made? And can we now use modern science to apply those things? The medical industry are looking at us. Collagenic wound dressings, they're rather important. The leather industry, the first to use biotechnology, and the first to be modifying proteins, known to be modifying proteins. So if you've got problems with the collagenic wound dressings, who do you call? And it's not Ghostbusters, just before anybody jumps in. Food industry, particularly sausage skins, derived from collagen, and the early steps of manufacturing that is identical to the way in which you make the early steps of a piece of leather. And finally, cosmetics. How many of us have seen moisturizers that have got added hyaluronic acid in it, a byproduct, by the way, of the leather industry? And hair removal cream? Well, of course, that's technology that's been learned and transferred from the leather industry because we remove the hair from the hides. So these industries that you might think are completely separate are not. Now, this is important that this is a point which I say thank you to you, not just for listening, but there are a number of people and individuals and groups of individuals that have helped me along the way. And it's really important to me because a professorship is a title awarded to an individual. It's a very personal thing. But for me, it absolutely would not have been achieved if it were not for the support of people along my way. Of course, I should thank my mother, my late father, my sibling, well, my late father's not here, but my mother and my sibling are here. Because those of you with siblings will understand the kind of challenge you have to fight to be the best. And this is something that's driven me on. I do return back to the fact that I wasn't the perfectly behaved young child, and my mother and father, to say they were saints would probably go a bit of an understatement. And their support and nurture through that process and their belief in me is one of the reasons that I'm here stood in front of you. I have 3 teachers from my secondary school. I believe there are some online, and there is even a primary school teacher or 2 online. Now, teachers do a fantastic job. They believed in equality, diversity, and inclusion before that really was even a saying. I was a challenge. They took that challenge on. They embedded me in what they did and what they knew. I knew the parameters. I just liked to break them every now and then. What teachers do is really important. And can I just say one important thing? What I learned from that is never give up on a child. Never. I think that's really very important. Professor Andrew Abbott, who will hate the fact that I'm singling him out, buried head in hands, for lots of reasons, and I don't need to go into them. I, again, would not be stood here. He is my external mentor. He's the person who, no matter what harebrained idea I have, when I ring him up and say, how about this? He always has time for me and always has the ability to listen. Thank you, Andy, because genuinely, there is no way I would be here without you. And the whole of the ICLT crew, both past and present. And I think that's really important. I would not have been able to achieve this. All of those projects that I've gone through so far have all been done in collaboration with colleagues of mine from the University of Northampton, and mostly from within that department. And individuals, there are 2 that I really want to select. In 2014, Rachel Garwood was brave enough to take me on as a senior lecturer. She was also the person that initially gave me the idea that I could be a professor. Until that very conversation, I remember it actually quite clearly, sat in her office, had not even given it a second thought. I was just focused on trying to deliver that book to undergraduates who really didn't want to listen to me. And Tony Covington, Emeritus Professor Tony Covington, who then was able to take Rachel's vision and help me deliver on it. I think that's very important. And I won't turn this into an Oscars speech, but my 3 children, Ella, Emily, and Sophie. Yes, talking to you. You can stop playing on that now. I know I'm not around very much. I work very hard to do what I do, but you never complain, you never ask where I am, and you always smile. And last, and I will say the most important person, is my wife. She's been with me, bless her, for 21 years, and you three thought you had it tough. And it is without question that she has supported me throughout, quite at the detriment of her own career, I hasten to add. And without that support, I again would not be stood here. She just accepts that I have to go to the places she would very much like to visit, Northern Italy being one, Florence being another, for example. So this is very important, and I think it's really important. That is not to detract from everybody else that is in this room. It is not to detract from industry members who couldn't join. It's not to detract from people that are online. You have all played a very important part in me getting this professorship. And so it's my opportunity to say thank you.
Thank you, everyone. Thank you, Will. I think if the brief is to make a complex subject understandable, engaging, amusing, and try not to deliberately kill your dean, then you've nailed it. Well done, Will. That was superb.
Thank you.
We have about 10 minutes in which we can take questions both from the floor and from online. So questions for Will about his work, about his inspiration. Who would like to go first?
Am I going to drink the tea? It's a very good question. Annie Lama, just so you don't have to run across. Am I going to drink the tea? No, I hasten to add in my enthusiasm to get through. What I was actually going to talk about is when we take veg tannins, we actually extract out the tanning agents, and it's what we all do when we make a brew. So all I've done is chuck tea into boiling water, and out of that comes the extractables, and a part of that extractables, not everything that comes out is tanning agent, but a part of that is tannins. So there will be tannins in my cup of tea that's sat there nicely. So thank you, Annie, because you spotted the fact that I'd completely forgotten to talk about that. Appreciate that, and it gives me that opening. So, that process, that's how simple it is to start the process of extraction of vegetable tannins. So that's what I was hoping to demonstrate there. Sorry? Is it going to keep me young? Well, I don't know what you're trying to insinuate there, if I'm honest, Annie.
Anyone in? Hang on now, I'll bring you the microphone. Too old to run.
I promise it's not flippant, Will.
Okay.
But when you shop for leather products, is it hard because you are so attuned to what's quality leather?
Now, it's an excellent question, and I can tell you now I've ruined my wife's shopping trips, because when we go out and find something, a lovely leather handbag, and I'll go, I wouldn't pay that for it. So yes, it has made me more attuned. I think one of the things that it definitely has attuned me to is the idea of sustainability. It's looking at where things are from, what they made from, and where they're likely to have travelled from. And it comes back to the fact that I think leather is one of the most sustainable materials that we can buy. So whilst I laugh about the quality of the leather, and I do look at that quite a lot, for me, it's much more about the sustainable angle when I'm looking at things. And that can be clothing, it can be what goes in my car all the way through.
Hey, Will. So, you mentioned that the use of cows and using every part of the animal, the skin is a byproduct. With those who are looking at reducing the consumption of red meat, for instance, of beef, do you think that has a knock-on effect on the availability of leather then, moving forwards?
At the moment, the decrease we see in people eating particularly red meat, but meat of any kind, is not currently having a substantive impact on the leather industry. without question, if the entire planet returns or goes to being vegetarian, that will. Okay, but at the moment, the kind of decreases we see, the kind of publicity those decreases get far exceeds the actual impact it's having in real life. So for me at this stage, it is not going to have much of an impact. And I think what's important to also identify is that animals are really an important part of sustainable farming as well. I went to a conference last year and they had somebody who was a farming expert who looked at the fact that we need cattle. If we are to actually increase arable food production, crops, we actually have to have animals as a part of that process because they so much more quickly break down the waste and turn it into something that can be put back into the soil and regenerated, that it's absolutely essential that we have animals. So intensive farming does a lot of damage, but sustainable farming, which the leather industry absolutely can be a part of, will, I'm sure, continue for many, many decades to come.
Any more questions in the room? Yes.
Just a quick question. Is there any use for waste leather? You know, like as in once people, there's a lot of issues around textiles and being exported and stuff. What's being done around, you know, kind of finding that and doing something with it?
Yeah, that's a really good question, actually. And just so that people know, this is a PhD student I was Director of Studies for, and undoubtedly is now taking an opportunity to get her own back on some of the nasty questions I asked her in supervisory meetings. Rebecca, thanks for that. No, it's a really valid question. There's an awful lot of work that's being done globally on this, and it actually needs to be broken down into a number of different components that aren't totally dissimilar from what you saw or did in your PhD project, because you've got the construction of those items is really important. If you look at a shoe, there is, certainly in my case, a rubber sole. It's then got leather, you've got metal eyes, you've got shoelaces. Is there a way in which we can make these things that makes them easier to recycle? Then you've got the problem of, if I can, how do I actually recycle the leather? And there are many scientific ways in which, certainly with chrome leather, we are able to recycle it. I'm not saying it's yet reached a point where it's commercially viable, but from a scientific perspective, we can take the chrome out, we can strip away the collagen, and we are left with that extremely small amount of plastic that we put on the surface to protect the leather, the polymer that we put on the surface. So there are ways of doing it. The challenge is trying to do it in a way that is commercially viable. And as you know, it's a challenge that faces the whole recycling sector, irrespective of what the material is that you're working on.
Thank you, Will. I'm going to count down from 3 to 0, and if there are no hands go up, I've got 3 comments online to share. So 3, 2, 1, 0. Okay, so Katie McKenzie says, huge congratulations, Will. Fantastic lecture. Big smiley face and 2 kisses.
Oh. But I have no idea who she is, Bex.
Anthony Mingins.
Uh-huh.
Guest says, great lecture, Will, great insight into your field and to understand what work you do behind the scenes. Wish I'd been able to attend for real, but we'll get over to see you and family ASAP.
Lovely, thank you.
And Don Hibbert, also a university colleague, says, great lecture, Will, great insight. There's another one popped in. I'll come back to Don in a second. I wondered why that had gone wrong. Oh, you're all at it now, aren't you, on people online? Just to catch me out. Okay, Adriano Peruzzi says, thanks, Will, for the lecture. One small note, leather is not often better than synthetic. It's always better than any synthetic mode. Adriano, you know I can prove it by numbers. Thanks for the tea.
Adriano is absolutely correct, of course.
Giro Frisch
yes,
says, great lecture, very inspiring. Thanks, Will. David Sabanda says, wonderful, Prof. Recently, we've seen various new materials like vegan leather, like the use of cactus, etc., and there's a lot of misinformation out there. How do you think such misinformation can be addressed?
I have a really simple answer to that, and that's with numbers and science. For me, one of the reasons I like science is the fact that it's undeniable. If you've got data there, you can prove something, it's unequivocal. You know, that's it, it's done. And I think what we need to do is spend a lot more time looking at the research and the numbers that are around these things so that you can measure stuff. And this is where it starts to branch out into something I've deliberately skirted around, and that's how we actually measure sustainability within the leather industry and whether that can be rolled out more widely into other materials. And I think once we've got to that point, and we are quite close to being able to actually nail that down, I think then that will make it very easy to make a point. But one of the things I think that's important is you always have to look at the use of the material. You know, if you've got something that's a very quick, single use, that you don't need the kind of performance characteristics of leather or the longevity of leather, then you don't always have to use leather. There are other things out there. But for me, sustainability is about longevity and high performance, and that's where leather wins.
Thank you, Will. Alison Power says, missed your dicky bow. I'm just going to leave that one there. And the last word goes to Don Hibbert, who says, we'd also like to echo Will's thanks to his wife and 3 children. Thank you all for releasing him to do all that he does, not just releasing, but also supporting. Thank you, Will. Thank you, Will's family. Well done.
Thank you.
Bloody nailed it. There will be an opportunity to continue to ask Will questions. I'm not sure how much wine there is left, but you're welcome to stay until it's done. And thank you to our colleagues who've been working behind the scenes to make sure all the technology works. It's very, very important, so thank you all.